Hello, and welcome to today's lesson on atomic symbols and representations. In today's lesson, we will aim to understand the concepts of atomic number and mass number. We will also learn how to represent atoms using atomic symbols. Finally, we will use this new knowledge to learn how to determine the number of protons, neutrons, and electrons in an atom using its atomic symbol. Previously, we explored the basic structure of atoms, including protons, neutrons, and electrons. Now, we'll build on that foundation to learn how these subatomic particles are represented in atomic symbols. Let's start by introducing two key terms, atomic number and mass number. Atomic number is the number of protons in an atom, and it's what defines the element. For instance, any atom with an atomic number of 6 has 6 protons and is therefore carbon. Similarly, any atom with an atomic number of 8 has 8 protons and is therefore oxygen. Remember that atoms are neutral, meaning that there's an equal number of electrons and protons. Hence, the number of electrons, in the case of a neutral atom, will also be equal to the atomic number. Mass number is the total number of protons and neutrons in an atom's nucleus. Electrons are not included because their mass is negligible. It's calculated as mass number equals the number of protons plus the number of neutrons. We can use it to find out the number of neutrons by rearranging the equation so that the number of neutrons equals the mass number, take away the number of protons. Now, let's talk about atomic symbols. You've probably seen these before in the form of an element's chemical symbol with 2 numbers next to it. Here's how to read those numbers. The top number is the mass number, the total of protons and neutrons. The bottom number is the atomic number, the number of protons. Let's go through an example to make this clearer. Let's examine the example of sodium. The top number, which is the mass number, is 23. The bottom number, or the atomic number, is 11. From this, you can figure out the following. The atomic number tells us there are 11 protons. We already know that the mass number equals number of protons plus the number of neutrons. Hence, the number of neutrons equals the mass number, take away the number of protons. Therefore, we get that the number of neutrons equals 23 subtract 11, which equals 12 neutrons. Since sodium is neutral, the number of electrons is equal to the number of protons, so we know we have 11 electrons. See how much information you can get from just those 2 numbers. Now that we have the basics, let's try more examples to solidify our understanding. You are given the following chlorine symbol. How many protons, neutrons, and electrons are in the chlorine atom? First, we identify mass number and atomic number. The bottom number, 17, is the atomic number, and the top number, 35.5, is the mass number. The next step is to work out the number of protons. As the atomic number is 17, we know the number of protons is also 17. Then we need the number of electrons. Since a chlorine atom is neutral, the number of electrons equals the number of protons. Hence, the number of electrons also equals 17. Now, we need to calculate the number of neutrons. The relative atomic mass of chlorine is 35.5 because chlorine exists as a mixture of 2 isotopes, chlorine 35 and chlorine 37. The atomic mass is the weighted average of these 2 isotopes. However, when calculating the number of neutrons, we use the isotope chlorine 35, which is more common. The mass number is equal to the number of neutrons plus number of protons, so rearrange the equation to work out the number of neutrons. From this, we get the number of neutrons equals 35 subtract 17, which is 18. Our final answer is the chlorine atom has 17 protons, 17 electrons, and 18 neutrons. Let's try another problem. A fluorine atom has 9 protons, 9 electrons, and 10 neutrons. What is its atomic number and mass number? Step 1 is to find the atomic number. The atomic number is the same as the number of protons. Therefore, if there are 9 protons, the atomic number equals 9. Next, we work out the mass number. The mass number equals the number of protons plus the number of neutrons. As we know, there are 9 protons and 10 neutrons. The mass number equals 9 plus 10, which is 19. Hence, this fluorine atom has an atomic number of 9 and a mass number of 19. Time for one last problem. A neutral sodium atom has a mass number of 23 and 11 electrons. Find the number of protons and neutrons. We start by finding the number of protons. For a neutral atom, the number of electrons is equal to the number of protons. Therefore, the number of protons is 11. Next, we calculate the number of neutrons. We can rearrange our equation mass number equals the number of protons plus the number of neutrons to find out how many neutrons are present. When we plug in the values, we get 23 minus 11, which equals 12. Our final answer is this atom has 11 protons and 12 neutrons. Being able to read atomic symbols is crucial for understanding chemical reactions, bonding, and more advanced topics in chemistry and physics. In today's lesson, we covered how to interpret atomic symbols to determine the number of protons, neutrons, and electrons in an atom. We started by introducing the concepts of atomic number and mass number, emphasizing that the atomic number tells us the number of protons, and the mass number represents the sum of protons and neutrons. We then practiced reading atomic symbols using examples like sodium and chlorine, illustrating how to calculate the number of each subatomic particle. This foundational skill will set the stage for more complex topics as we explore isotopes and ions in upcoming lessons.